The remainder and factor theorems. We know that we can divide numbers. For example, 11 divided by 4 is 2 remainder 3. 4 goes into 11 2 whole times and leaves a remainder of 3. So you can write 11 is equal to 2 times 4, add 3. In other words, our initial number 11 is equal to the quotient is the 2, the number of times 4 goes in, multiplied by the divisor, add the remainder. This is really important, so make sure that you remember that. We discussed in the last section that numbers are simply polynomials of degree 0. This property of division is inherited from polynomials. So we can do division with polynomials, although you're not going to actually need to do that as yet. There's ways around it. If we divide a polynomial of degree n by a polynomial of degree m, the quotient will be of degree n minus m. So if we have a cubic, which has degree 3, and we divide it by a quadratic of degree 2, we'll end up with a polynomial of degree 1, a linear. If you have a polynomial of degree 5, and you divide that by a quadratic, then your quotient will be a cubic. The degree of the remainder will be less than or equal to m minus 1. So in other words, up here, well, there is only one thing less, so your remainder will be of degree 0, it would be a number. Here, your remainder could be a quadratic, a linear, or just a number. And we explain that further here by saying if dividing a quartic of degree 4 by a quadratic degree 2, the quotient will have degree 2 and the remainder may be of degree 1 or 0, so linear or just a number. The remainder and factor theorems apply to polynomials in general, but we will restrict our work to cubic functions being divided by linear functions. So degree 3 divided by degree 1. And that will leave us a quadratic quotient and a remainder, which is just a number. So we'll get something like cubic of x is linear of x times quadratic of x plus a remainder. And that remainder is just going to be a number. So remember this.